Test 3 is the point, this is the review, is the point 9, -2, a solution. There should be a y right here, so it's y is greater than -7 plus x, or sorry, -x plus 7. And the 9 represents x, and the -2 is y. So we're going to plug those numbers in for x and y and see if it works. So here we got -2, 2 is greater than negative, plugging in a 9, plus 7. So is, if you were to, let's see, we got -2. Okay, so -9 plus 7 would give us -2. And over here we have -2. Is -2 greater than -2? There was not an equal sign. There's no equal line. So in this case, is the point 9, -2 a solution? The answer is no, it is not. Is the point -4, -2 a solution to the system? Same thing, only we're going to plug in the x and y into both of them and make sure it works on both. So we got -3 with a -4 plus 5 and -2 greater than -11. That's a greater than right there. Okay, so if I multiply here, I got 12 positive. 5 times -2 is -10 and greater than -11. 12 take away 10 is 2. Is 2 greater than -11? Well, positives are always greater than negatives. Therefore, yes, it works on the top equation. So now we have to make sure it works in both, because a system, it has to work in both. So I'm going to put in the x and y values for both. Over here, -4 minus 10 is -14. And 7 times -2 is -14 also. Is -14 less than or equal to -14? So because there's the equal line here, then yes, that works. And so is the point a solution to the system? Yes, it is. The students at Seaside High School are selling candles and scented soaps to raise money for a new computer lab. They will earn $2 for every candle, and each bar of soap will get them $4. So $4 for each soap, $2 for each candle. They need to raise a minimum. Minimum means that's the lowest, smallest number they can get is 3,100 or 3,100 to earn enough money to finish construction of the computer lab. Write an inequality that describes the situation. Use the given numbers and the following variables. X will be the candles, Y is the number of soaps. So $2 for every candle. We called the candles X. Plus they're going to make money on the soaps, $4 for every soap they sell. So we call that Y. They need a minimum of 3,100. So they need 3,100 equal to 3,100, or they need more, because 3,100 is the smallest they want to go to get their computer lab. Minimum is the lowest. So you want bigger or equal. Max buys a package of 4 batteries for under $252. 4 batteries. There's 4 batteries in a package. What is the price for each battery? So a package has 4 batteries. We don't know the price of each. And it needs to be under $252. Well, if I divide that out by 4, x is less than, in this case we get 60 3 cents. Well, can X really be less than 63 cents forever and ever? If you're talking about how much each battery costs, we're talking about money. So in this case, since X can't be less than forever, we're actually going to stick another sign on here and say, well, we want X to be in between the 63 cents and we want it to be in between with 0. So we don't want it to be a negative number when we're talking about price. So the price can be in between 0 cents and 63 cents. And that's how we can write that out. Matt bought 5 of the same packages and the weight of all 5 packages started at 40 pounds. So 5 of all the same packages, all 5 packages. Okay, how much was the weight of one package? So 5 of the same package. We don't know the price. Wait, no. We don't know the weight. So 5 times the weight of the package, of each package. And it says it started at 40 pounds. Start at 40. So 40 is the beginning. So we equal to 40. 40 is where it starts, or it's going to be more. Starts at 40, or it's going up from there. So if we divide out 5, X is greater than or equal to 8. In this case, we're talking about pounds. So it's X is greater than or equal to 8 pounds for each package. Number 6, graph the inequality. Same thing as if I were to graph with an equal sign. So we need to solve for y first. So I'm going to add 3x over. Negative 6y less than or equal to, well, I could put 0 plus 3x, or I could just put 3x, either way. And now I got to divide out negative 6. When I divide a negative, my inequality sign flips over. Make sure you remember that. 0 divided negative 6 is 0. And positive 3 over negative 6 leaves us with a negative. And 3 over 6 reduces to 1 over 2. So we're going to start at 0 and go down 1 over 2. And then because it is equal to, it's got the line right there. Equal to, that means it's equal to the line. The points are solutions, so we're going to draw a solid line through here. That means solid line. That means the points on the line are solutions. They're x, y values. You can plug them in and they work. And then because the symbol is greater, we shade all the solutions. There's lots more than just what's on the line. It's all of them. It's everything greater, so it's everything above the line too. So all of those points in the shaded and on the line are going to be solutions. If I pick this point right here, that xy value, which is 2, 3, and you plug it into your inequality that you started with, it will work. Meaning this side, the left side, will be less than or equal to 0. It will work. Okay, number 7, write the inequality of the graph. Well, when I want to write the inequality, I'm going to have y, and I have a solid line here, so I'm going to put the equal to. The shading is above the line, so I know I'm going to have greater than or equal to. And then I need my slope and y-intercept. So where does it start on the y-axis? It starts at 4. And if I go down, another good point to use would be right here. And if you keep going, There's another good point right there. So if we would go down 1, 2, 3 over 1. 1, 2, 3 over 1. So we're going down 3 over 1, which we don't need to put the 1 underneath the 3. So we would just have 4 minus 3x. Or if you prefer, we could put negative 3x plus 4. Both of those are the same. Number 8, graph the system. So on the top one, notice the y is not by itself. So we have to move that negative 3x over to the other side. So we're going to add 3x, move it over. Y is less than or equal to negative 3 plus 3x. So I'm going to start at negative 3, and it's going positive 3, so up 3 over 1, 3 and 1, 3 and 1, 3 and 1. Then I'm going to check, do I need a solid line? And in this case, yep, I got the equals. So I'm going to draw a solid line through here. And then it says it's less than, right here, less than. So all the solutions would be equal to the line or below the line here. And now we're going to graph the other one we got here. This y is less than 2. So it's just a y. We're going to go to the 2 on the y-axis. And it's just y. So I need a line that only crosses over y. That's the one that goes straight across horizontal, so it crosses the y-axis. But notice I don't have an equal to line here, so I need to draw a dashed line to show that those are not solutions, but it helps us find where the solutions are. So it's less than, so everything below the line, not on the line, everything below the line, just less than it, are solutions. And because it's a system, we're looking for the solutions that work in both. So in this case, I would end up darkening in this overlap shading right here, and those are my solutions to the system. Those are the solutions that are going to work in both, not just one. All right, number 9, show all possible solutions. Same thing. We're going to solve for y, add 4x, add 4x. We get 3y is greater than 12 plus 4x plus, that's a plus, okay? And then we divide out 3. Here we got a 1, so y is greater than, the 3 is positive, so we don't flip our sign. 12 divided by 3 is 4. And positive divide positive stays positive. And it's 4 over 3. That does not simplify, so it stays 4 over 3x. So we're going to start on the 4. And we're going to go up 4 positive over 3. 4 up, 1, 2, 3, 4, 1, 2, 3. We're going to go the other way, 1, 2, 3, 4, 1, 2, 3. 3, 4, 1, 2, 3. In this one, it is not equal to, does not have the line, so make sure your line here is dashed because these are not solution points, but they help show us where the solutions are. And it says they are greater than. So everything above the line or on top here, these are where the solutions are right here. Any xy point you pick up here is going to work if you plug it back in to our original inequality. Negative 4x plus 3y is greater than 12. So any point I pick here, whether it's this point, right, somewhere way up here. So any of those xy values, if I plug them in here, will work.